everyone. Today we will learn glomerular filtration. It's the first step of excreting urine. How does it work? What factors affect it? Why does acute nephritis accompany with oliguria, proteinuria, and hematuria? Why does urine increase during massive infusion? In this class, we'll settle them one by one. Glomerulus is wrapped by Bowman's capsule. Podocytes in the visceral layer extend out projections to wrap capillaries. There is a membrane in the slits between projections with a certain permeability. Therefore, the filtration membrane includes three layers: capillary endothelium, the basement membrane, and the membrane in slits, each layer with holes like three sieves overlapping together form the mechanical barrier. Therefore, the blood cells can't be filtered. The filtration depends on the molecular size and the electric charge. Molecular radius less than 2 nanometers, such as electrolytes and glucose, can be filtered freely, while greater than 4.2 nanometers, such as blood cells, can't be filtered. Between 2 and 4.2 nanometers, the filtration decreases with the increase of radius. With the same radius, if taking negative charge, the filtration is the least. If taking positive charge, the filtration is the most. This is due to the fact that the three layers of filtration membrane attaching with negative charged glycoproteins to form the electrical barrier. The radius of plasma albumin is about 3.6 nanometers, which can be filtered if taking positive charge or no charge. But albumin carries negative charge, so it can't be filtered. So there's no albumin in the urine. Glomerular filtration rate and the filtration fraction can be used to measure the filtration. The amount of primary urine filtered by both kidneys per minute is called glomerular filtration rate, short for GFR. The average is 125 milliliters per minute. The ratio of GFR to the renal plasma flow is called filtration fraction. In normal adults, the filtration fraction is 19%. There are two factors, one promoting the filtration, the other blocking it. The difference is effective filtration pressure. Similar to the formation of interstitial fluid, the promoting force is capillary pressure, while the blocking force includes plasma colloid osmotic pressure and the pressure in capsule. So, the effective filtration pressure equals glomerular capillary pressure minus the sum of plasma colloid osmotic pressure and capsule pressure. When the pressure is greater than 0, that's filtration. Equal to 0, the filtration stops. The pressure can't be less than 0, because if capsular pressure increases, the urine flows away along the renal tubules. Three factors affect the filtration. The first is the permeability and area of filtration membrane. If the electrical barrier was destroyed, there would be protein in the urine. If the mechanical barrier was destroyed, there would be blood cells in the urine. If the glomerular capillary became narrow or obstructed, the effective filtration area decreases, causing the decrease of GFR, oliguria, or anuria appear. The urine less than 500 ml is called oliguria. Less than 100 ml is called anuria. Therefore, acute nephritis accompanied with oliguria, anuria, and hematuria. The second is the effective filtration pressure, which is decided by three factors. The first is glomerular capillary pressure. Arterial pressure changes between 80 and 180 mmHg. GFR is stable relatively due to the auto-regulation. Thus, the urine is stable. Arterial pressure was lower than 80 mmHg. Glomerular capillary pressure decreased. So, the decrease of effective filtration pressure and GFR caused oliguria. If arterial pressure was lower than 40, there would be anuria. The second is plasma colloid osmotic pressure. If a large amount of saline was rapidly infused, the plasma protein would be diluted. If the protein synthesis in liver was damaged, or the plasma protein was lost due to kidney disease, the plasma colloid osmotic pressure decreases. The effective filtration pressure increases, so GFR increases. The third is capsular pressure. At normal, it's nearly stable. In renal calculus or tumor, the tubular fluid or final urine can't be discharged. Capsular pressure increased. Thus, the effective filtration pressure and GFR decrease. Not all the capillaries in glomerulus have filtration function. With the filtration, plasma colloid osmotic pressure increases and the effective filtration pressure decreases. The membrane has filtration before the point that the effective filtration pressure drops to zero, while the later membrane has no filtration. With the increase of renal plasma flow, the increasing of plasma colloid osmotic pressure and the decreasing of effective filtration pressure slow down. The point that the effective filtration pressure at zero was close to the afferent arteriole. Therefore, the filtration area increases. GFR increases. This is another reason for the increasing of urine caused by massive infusion. Let's do a summary. Glomerular filtration is the first step in excreting urine. Three factors affect it. We should grasp them and be able to use them to explain some phenomena. That's all for this class. Thank you. See you.